Hello everyone, this is problem C of Educational Codeforces round 149. Okay, so in this problem we're given a string which consists of zeros, ones and question marks, and a binary string will match the given string. So the given string is something like this. So a binary string will match this given string if we can replace the question marks with zeros and ones to get the new string. So this will match the given string. Also, there is another definition. So an operation on a binary string is a reversal of a continuous substring. So the cost of a binary string is defined as the minimum number of such reversal operations to sort the string in non-descending order. So we have to find a binary string with the minimum possible cost among all the strings that match the given string. So let's take an example. Let's take the last example. So for this example, we can replace the question marks like this to get a string which has the minimum cost. This string has cost 2. We can reverse this substring. This will give us a string like this. Then we can reverse this substring, and then the string is sorted. So at first, let's take a look at how we can minimize the cost of a string which doesn't have any question marks in it. So we'll take this string, for example. So let's take this string. Let's take a look at these two positions. So this is an inversion. A 1 comes before a 0. So this shouldn't happen in a sorted string. All the zeros will come before all the ones. So we need to do an operation to sort these two positions. But the one before this one will also be an inversion with this 0. So we can fix both these ones with one operation. So if we take this subarray, these two ones will go to the back, and this will fix the inversion of this substring. So at first we'll take this subarray. So after we do the first operation, this is what our string is going to look like. Now this will also cause an inversion, so we'll take this substring and reverse it again. Now also this inversion is fixed, and this will give us a sorted string. So this will be our algorithm to get the minimum cost. Starting from the end, we're going to take substrings in the form of there are some zeros in the suffix and there are some ones in the prefix. And to minimize the cost, we're going to take the largest substring of this format. So for example, at first we took this substring, then we took this substring. Okay, so this way we can minimize the cost, and this will help us to build the string from the given string. So let's take this string as the input string, and we need to place zeros and ones in the question marks to minimize the number of operations. So let's remember how we calculated the minimum number of operations. We took some zeros as a suffix and some ones as a prefix. So here a 0 is here, so we can start the substring from here, and we need to have some amount of ones as a prefix. So we can see a 1 here. We can end the substring, we can start the substring from here, but we can also start the substring from this question mark. This will never be yours. If we do that, we are assuming that we are replacing this question mark with a 1, and if we replace this question mark with a 1, this will also be just one operation. So we can do this. So we'll replace this question mark with a 1 and assume we're going to reverse this substring. Okay, so after we do that, then we're going to start another substring from this position. So there will be a suffix of zeros and a prefix of ones. So now here is the suffix and we'll have a prefix of ones, but if we include this question mark, then we can also include this one in our prefix. So we're going to do that, and also this question mark is also going to be included in the prefix. So all of this, we'll consider all of these values as ones. So these two question marks will be replaced with ones. Then again we're going to start another substring from here, but we don't have any ones in the prefix and we don't need any ones, so we're not going to do anything here. So this is it. So to summarize, we're going to start iterating from the back, and when we find a 0, we'll say that we're going to start the substring from here, and it will contain a suffix of zeros, and then we need a prefix of ones. So we're going to maintain zeros as long as we can. So if there are some question marks, we'll replace them with zeros, and when we get a 1, then this will begin the prefix of ones, and will also contain 1 as long as we can. If we get some question marks, we'll replace them with ones until we get a 0. Then we're going to start another substring. Then we're going to repeat the same process. So this was problem C. I'll quickly show my code for this problem. Yeah, we'll take the string as input. I added a 1 at the end for convenience. Now we're going to start iterating from the back, and the now variable will store the character which I'm iterating at right now. It is either 0 or a 1. So if the current string matches with the now variable, then we'll continue. Otherwise, if we get a question mark, we'll replace this character with the now character, and otherwise we'll change the now character. So this is it. After we're done replacing all the characters, we'll just pop the 1 from the back and print the string. So this was problem C. Okay, this is problem D. So in this problem, a bracket sequence is called beautiful if this bracket sequence is either a valid bracket sequence. So this is a beautiful bracket sequence because this is a valid bracket sequence, or it will be a beautiful sequence if this sequence is read from the back and then it becomes a valid bracket sequence. If this bracket sequence is read from the back, this is what we get. This is a valid bracket sequence, so this will also be a beautiful sequence. So in this problem, we're given a bracket sequence and we need to divide this sequence into some amount of subsequences where each of the subsequences are beautiful sequences. So It might also be the case that it is not possible to do that. In that case, we need to output -1. So let's at first rule out the case of -1. So in a valid bracket sequence, the number of left brackets is equal to the number of right brackets. So if the given string does not have an equal number of left brackets to right brackets, then it is not going to be possible. In that case, we need to output -1. Otherwise, it is always possible to divide the sequence. So here is the main observation. We can use at most 2 sequences to divide the sequence in to get beautiful sequences. So we have 2 cases. We need 1 operation or we need 2 operations. So the case of 1 operation, in that case, the given string needs to be a beautiful string or a beautiful sequence. So we just need to check if the given string is a valid bracket sequence. If the string is a valid bracket sequence, then we need 1 sequence. And if the string is a valid bracket sequence read from the back, then it is also possible with 1 sequence. So these are just 2 cases. So we'll check if this is the case. If this is the case, then it is possible with 1 sequence. If it is not the case, then it is possible with 2 sequences. So let's see how it is possible with 2 sequences. Let's take an example. Yeah, so it is not possible with 1 sequence. We need 2 sequences. So what we're going to do is we're going to take out a subsequence from this sequence which has a prefix of left brackets and a suffix of right brackets, and the size of this is maximum. So from this string we're going to take out such a sequence. So we can build the sequence like this. We're going to take the first left bracket and the last right bracket. Then again the next first left bracket and the next last right bracket. So if we keep doing this, we're going to get a sequence like this. So this is the maximum size sequence that we can take out from this string. And if we do this, we are going to be left with a sequence of this form. Here we are left with 1 right bracket and 1 left bracket, but we might also be left with a bracket sequence like this. So we're going to be left with a sequence which have a prefix of right brackets and the suffix of left brackets. So the sequence that we picked out is a valid bracket sequence, and the sequence that we're going to be left with is a valid bracket sequence if it is read from the back. So then these are going to be our 2 sequences. So we'll just assign 1 color to this sequence and assign another color to this sequence, and this is going to be our answer. Yeah, so let's take a look at the code. So we're going to take the string as input. Then we're going to check if the count of left brackets is equal to the count of right brackets. If it is not, then we need to print -1. Otherwise, we're going to check if we can if this string is a beautiful string or not. So we're going to check the balance from the left and we're going to check the balance from the right. So if it is valid in either of these 2 cases, then we can just use 1 color or 1 sequence. So we just print all ones. Otherwise we need 2 sequences or 2 colors. So here I'm calculating a prefix sum of the right brackets. So using this prefix sum array, I'm going to be able to tell how many right brackets I have starting from a specific index. So using that, I'm calculating the maximum size of the sequence that I'm going to take out. So it will be stored in this variable. So for that amount of left brackets and that amount of right brackets, I'm going to assign one color to it. So this is me going from the prefix and assigning the color 1 to those indices, and this is going from the back and assigning the color 1 to the right brackets. And at first I initialize the vector with 2, so all the leftover indices will have a value of 2. So now I can just print the amount of colors, which is 2, and I can print the array out. Yeah, so this was it. Thanks.